So we'll be talking about Karaoke Dreams. This is probably a more whimsical uh, paper among the rest. So, oh, there we go. Um, we'll be first giving an introduction and showing a video demo, and then we'll talk about the neural network generated content creation part, and then the system implementing the generation and using it as an artwork. So Karaoke of Dreams is a site-specific art project that we made in one of our in our art residence at Bombay Beach, California. As you can see, it's located in the Californian desert. It has amazing sunsets. We have a site where Bombay Beach, California is a town that is semi-deserted but reinvigorated by artists in recent years, and there are a lot of crazy stuff going on in the town. Our project is sort of a homage to this town and the city and this community of artists, to say. Yeah. This is our karaoke, the little box over here, in among other our projects in one of our showcase nights earlier this year. So this is the context of Karaoke of Dreams. We wanted to use neural network to see if we can inject a little bit of techness in this vast land of nothingness.
Karaoke of Dreams is a deep learning karaoke that generates songs and video based on user input of song titles. Karaoke of Dreams is a multi-dimensional machine learning matrix operating in the oral dimension on melody, harmony, lyrics, and style. In the visual dimension, it's operating on images tied to words, in our case, the song titles that users have put in to generate the songs, using attention GANs. In the linguistic dimension, it's using GPT-2 fine-tuned on pop song lyrics, since most karaoke is pop songs. In the spatial dimension, it's a fourfold rotational tesseract outlining 3D space. The human element is the participant's voice and performance of the generated concert experience. The Karaoke of Dreams envelops the singer like an AI womb, a safe, warm, pulsating center allowing the singer to pour their heart out. The Karaoke of Dreams creates a fully ML-generated performance environment, including the space, lighting conditions, visuals, sound, melody, lyrics. The human's remaining job is the performance of the information given to them. We did this in order to explore the emotional effect of machine learning on the human mind. While most machine learning projects are cerebral in nature, Karaoke of Dreams is visceral, performative, and time-based. Regardless of the human's interpretation or feelings about the experience, whether they be silly, whether they find it fun, whether they find it inspiring, challenging, thoughtful, creative, they will feel something because they must do something in order to make this piece happen. So this piece pits the human element up against the machine learning element in an inexorable way in order to produce an emotional reaction. Whether or not that emotional reaction can be quantified or qualified remains to be determined. However, we believe that as a system, this is a very potent project because human subjectivity and experience is at its core, while the entirety of the environment, performative, oral, visual, and aspirationally even spatial, is created by machine learning. We chose karaoke because it is a worldwide phenomenon and most people know how to operate it. In fact, most people have direct experience with having sung karaoke before. There's no expectation of being in tune, of being a great performer, of knowing how to sing even. And yet, Everybody will know how to perform a song when they see a karaoke machine. Karaoke is a performance of intimacy, often done in front of friends, to songs that are collectively known, and yet not expected to be performed properly. It's an activity enabled by technology where the machine assists and supports the human, whether machine learning or not. It's a form of entertainment that exists virtually everywhere in the world, and most people know immediately how to interact with it. I will now play you an example of a video of a karaoke song in which two participants are singing so that you can hear the music and see what the sounds are like.
Oh, my darling.
Oh, my darling, I've been waiting
for you. For a long time.
I've been waiting for you.
I've been waiting for you.
For a long time.
For a long time.
Oh, my dear.
Oh, my dear.
Oh. The way you walk.
The way you speak.
Oh,
Oh, my darling.
Oh. The way you walk.
The way you walk.
The way you speak.
The hardware involved for Karaoke of Dreams include an iPad, a Raspberry Pi as seen in the box with a red light, 4 speakers, a laptop not pictured running VDMX, which runs the generative visuals as seen on the previous slides, and a projector. The iPad runs a web page user interface, which is made dynamic through React. The web page is hosted on the Raspberry Pi via Node. The Raspberry Pi hosts an ad hoc Wi-Fi network that the iPad connects to. Node communicates with the iPad via WebSockets and with Pure Data via OSC. Pure Data, an open-source visual programming language closely related to Macs, is responsible for the sound. It communicates via OSC to the VDMX laptop, which is connected to the same ad hoc Wi-Fi network. PD is also responsible for timing issues, including tempo and lyrics. The iPad UI consists of 2 screens, a song select screen, which allows the user to pick a particular song which is sent by index to Node, and a lyric display screen, which displays lyrics line by line. Since lines might be the same, the background for the text box changes colors each line. Since we only provide lyrics, the melody is free to be improvised by the user. A stop button is provided to go back to the song select screen and stop playback. Once the Node receives a song index from the iPad, it loads the appropriate lyric file and forwards the index to Pure Data. Pure Data sends a desired lyric line by index through OSC to Node, which sends the appropriate lyric line to the iPad. Since I was worried about Wi-Fi connectivity issues, Node handles all the interface changes on the iPad. Once Pure Data receives a song index, it loads the appropriate MIDI file, which is done by CycloneSeek. I soundify the MIDI notes of the MIDI file through synths, FM synths for the melody and drum synths for the percussion. Since I wanted every song performance to be unique, Pure Data does a bunch of randomization upon each song performance. These include ADSR envelopes for the synths, frequency modulation parameters for the melodic synths, which changes timbre. The tempo of playback is chosen randomly between 80 and 120 BPM. With a desired rate of 4.8 seconds per lyric line at 120 BPM, this rate is adjusted to the tempo chosen. The sounds go through a bunch of effects, including phaser, chorus, and flanger. The sounds also go through a bunch of different effects, which help to increase the tension of a song. These include bit crushing, delay, and distortion. Peaks of these effects and the parameters are determined randomly, and there's 1 to 3 peaks per song performance. We got a bunch of user feedback, and the full quotes can be found in the paper. Basically, Karaoke of Dreams acts as a sandbox for artistic expression. Since we only provide lyrics and the backing track, the user is able to interpret the lyrics how they wish, including generating their own melody. This active participation with generative art allows the user to respond to technology instead of passively observing it. This may induce a warmer attitude towards generative art, which may be seen as cold, emotionless, and machine-like. And with this, I'd like to pass the presentation off to Sophia.
We're interested in it because it's one of the most prominent form of machine-human collaboration in some sense, and then it's done for a non-productive goal. It's an interesting form where we can perform cyborg art together. So this is the interface where you see the lyrics coming on the top, and then when it's presented, it's mounted on like a smaller hypercube, as we say it, in the karaoke. And then the videos that are generated in the karaoke, in the sense, is projected onto the karaoke as atmospheric lighting and for people to view from the outside. So this is the feeling of it in some sense. You have the outside world, but you also have the inside world, and they're both visible to the viewer and to the singer. So there are 3 parts in the karaoke in some sense: the lyrics, the music, the visuals, and we want all of them to be neurogenerated in some sense, because at Bombay Beach we only had 1 GPU, and it's a shared resource with everybody, and we want to be, and it's powered by solar power, so we wanted it to be resource conscious. So instead of training models from scratch, we looked at downloadable on-the-shelf trained models. And then we used it in a modular way so we can swap in and out models as if we want to improve in the future or have newer versions. The lyrics are very straightforward. It's a GPT-2 fine-tuned on pop song lyrics data sets available on the internet. Here is an example. We had members of the local community to give us song titles just as a primer of the on-site art. So the list of songs people choose from are a list of songs people demanded from us in some sense. And this is a quote from a local homeless person. And the song is in memory of him. He's an innocent man. Great. And the music generation is through a GAN-based music model called MuseGAN. It's trained on the lock piano roll dataset, the Almighty. And then what it does is it's a convolutionary neural network that generates 4-bar piano rolls. This is a unfixed, uncleaned sort of example of what it's like. One of the bars in a 4-bar chunk, but as you can see, it has 5 tracks, and it was trained on pop songs. It has some of the pop qualities to it once you hear our demo. And then, so the chunks are mapped to the lyrics lines generated in the previous ones randomly. For visuals, the video projected onto the karaoke, we use the intention GAN, which takes in a caption and then tries to generate the image that fits the caption. As we can see, it's very abstract because a lot of our lyrics are abstract, but it has this dreamlike qualities that fits to the karaoke concept. And then after generating the images, we used a algorithm to have them transform from one to another. It's a video is generated for each song and projected onto the karaoke. Yes. In the paper, we talked to a bunch of people who have used our system, and the feedback was that because you and the machine need to collaborate, when the machine prompts you with music, you need to come up with the top line for the lyrics and the melody. It's an interesting experience, similar to machine-human collaboration. And then you need to trust the machine. It fosters this, and you are in this atmospherically lighted box, which feels like the inside of the machine too. It has this strange feeling, and that's sort of the vibe we're going for. Yeah. The full testimonies are also in our paper. They're fun to read. Yeah. And also there are a lot of things that we can do and can go forward with it. First of all, a lot have changed since March, I guess, in the machine learning space. GPT-3 is out, and then OpenAI has a very cool new model for music generation, which directly generates audio. It's called Jukebox. Magenta project also has a bunch of interesting models that we could use. So the music part can always be separated out. We're also thinking of having a web-hosted version of it, so the user can just input a song title, and then everything would be handled by the server. We can do Karaoke of Dreams via the internet. Yeah, and we're also thinking about other on-site constructions. What would it be like in a city? What would it be like in a town in different parts of the world? Also, our reviewers suggested we could do a more thorough UI UX study of the system and study the behavior of how trust works and how musical collaboration works between the user and the machine. And that concludes our presentation. Thank you.
Hey. Ladies. Hey. Oh, he come from the northern desert. A man with a bad name. Oh, he killed his wife and used her to buy his life. Oh, he wore a white coat. with a black belt. Yeah.